Hello, welcome to the introduction video for the atmospheric science event. My name is Davin Shi, and this year I'll be talking about some of the basics of the atmospheric science event and also what it entails. So a little bit about myself first. I'm the event supervisor for atmospheric science this year, which means I'll be recording a few videos talking to everyone about the most important parts of the atmospheric science event. I'm a first year at Harvard from Atlanta, Georgia. I did some science Olympiad in high school, so I'm very excited to be an event supervisor for atmospheric science this year. And I'm interested in majoring in either economics or government. So the event description first. This event requires competitors to demonstrate knowledge of the Earth's atmosphere, the role it plays in weather and climate, and its impact on human society. So we'll cover four main topics, which are the atmospheric structure and composition, the global energy budget, the atmosphere's role in the climate system, and global climate change. Today in this video, we'll be talking about one of the parts of atmospheric structure and composition, and we'll probably be talking about it for the first three videos, including this introduction video. So first off, we'll start with the layers of the atmosphere, which include the troposphere, the stratosphere, the mesosphere, the thermosphere, and the exosphere. And from the video, you can already make a few observations about the atmosphere. You see that meteors are in the mesosphere in the image, and you can see satellites in the thermosphere. So that gives you a pretty good idea of some of the details about the layers of the atmosphere that we'll be talking about today. So first off, we need to talk about the composition of air. The atmosphere contains the air that we breathe and also protects us from the bursts of heat and radiation emitted from the sun. The gases in the Earth's atmosphere include 78% nitrogen, 21% oxygen, 0.93% argon, 0.04% carbon dioxide, and trace amounts of other gases. So you can see that it's predominantly nitrogen and oxygen, and 78% nitrogen. And the first layer of the Earth's atmosphere that we'll talk about is the layer closest to the Earth's surface, which is the troposphere. It's 7 to 20 kilometers thick, and almost all of the water vapor and dust in the atmosphere are located here, which means that clouds are also located in the troposphere since they're associated with water vapor. So the next layer of the atmosphere we'll talk about is located above the troposphere, and it's up to 50 kilometers above ground. It's a stratosphere, and the stratosphere is home to abundant amounts of ozone, which absorbs the radiation that's emitted from the sun. And hot air balloons and commercial jet aircraft tend to fly in the lower stratosphere instead of the troposphere, since the troposphere is very turbulent, and jet aircraft and hot air balloons reach their maximum altitudes in the stratosphere. And some important details about the air in the stratosphere: it contains very little water vapor compared to the troposphere, where the air contains lots of water vapor. And air is 1,000 times thinner at the top of the stratosphere than it is at sea level. So the next layer of the atmosphere that we'll talk about is the mesosphere, which starts at 50 kilometers from the ground and extends to 85 kilometers high. It's above the troposphere and the stratosphere. And one important part of the mesosphere that we'll talk about in detail is the top of the mesosphere, which is also called the mesopause. And it's actually the coldest part of the Earth's atmosphere, with temperatures averaging minus 90 degrees Celsius. And it's actually very difficult to study the mesopause because jets and balloons cannot reach this layer. We said earlier that jets and balloons operate in the lower stratosphere, so they often do not reach the mesopause. And we'll learn later that satellites operate in the thermosphere, which is above the mesosphere. So since jets, balloons, and satellites do not reach this layer, it's really hard for scientists to collect data about the mesopause and learn more about its characteristics. But we do know that meteors burn up in the mesopause because the temperatures do average minus 90 degrees Celsius. And at the mesopause, the gases made of different types of atoms and molecules are thoroughly mixed together because the atmosphere is very turbulent at the mesopause. The next layer of the atmosphere that we'll talk about is the thermosphere, which starts at 90 kilometers above the ground, above the troposphere, the stratosphere, and the mesosphere. And it actually extends to 500 to 1,000 kilometers. So it's a very long layer. And temperatures can reach up to 1,500 degrees Celsius at this altitude. So it's very warm in some portions of the thermosphere. And air density is so low that some people consider the thermosphere to be outer space. But we'll talk about how the exosphere actually marks a difference between the atmosphere and outer space. And we know that some space shuttles and satellites fly in the thermosphere. And the thermosphere is actually where the ISS, the International Space Station, orbits Earth. And it's actually where auroras occur. And now we'll talk about more about the auroras that occur in the thermosphere. So they happen because charged particles from space collide with some of the atoms or molecules in the thermosphere, and this excites them into higher states of energy. And when these atoms or molecules shed this excess energy, they emit photons of light, which result in the auroras that we see at the top of the northern hemisphere or the bottom of the southern hemisphere. And the last layer of the atmosphere that we'll talk about is the exosphere, which is the highest layer of the atmosphere. And the exosphere is extremely thin and it marks the boundary between the atmosphere of Earth and outer space. And it's composed of very widely dispersed particles of hydrogen and helium, which is different from when we talked about the mesosphere, where the gases made of different types of atoms and molecules are more thoroughly mixed together because the atmosphere is very turbulent at the mesopause, which is the highest part of the mesosphere. So now we have a little chart which shows us the difference or the relationship between temperature and height from the ground in the atmosphere. So we can see that the temperature reaches a low point in the mesopause around minus 90 degrees Celsius. And we talked about that earlier, which is why, and this is where meteors burn up. But as we move from the mesosphere into the thermosphere, temperature changes with height and it can reach very high temperatures in the thermosphere. So this is a nice little chart that compares a relationship between the temperature and height from the ground in the atmosphere. So that's all of the information that we'll cover in this event or in this video. So to test our knowledge of what we learned today, I made up 5 different questions. So feel free to pause the video and think of the answers. And then to these questions, the layer where the ISS, the International Space Station, orbits Earth, the layer closer to the Earth's surface, the layer where meteors burn up, the layer where hot air balloons fly, and the highest layer of the atmosphere. So take a few seconds to think of the answers, and now I'll reveal the answers. So the layer where the ISS orbits the Earth is the thermosphere, and this is where a lot of space shuttles operate. The layer closest to the Earth's surface is the troposphere. The layer where meteors burn up is a mesosphere, and that's because the mesopause reaches a very low temperature. The layer where hot air balloons and also commercial jet aircraft fly is the lower stratosphere instead of the troposphere. And the highest layer of the atmosphere is the exosphere, which kind of marks the boundary between the atmosphere of Earth and outer space. So now that we've talked about the composition of air and also the different layers of the atmosphere and also a few qualities about them, that's the end of today's video. But in the next video, we'll continue the theme of atmospheric structure and composition. We'll talk about atmospheric gases and aerosols and how they impact the climate, and also atmospheric circulation and climate. And for example, we'll talk about the ITCZ and also Hadley cells that have an impact on the climate. So that's it for today's video. Thank you for watching.